Hi everyone. In this video we're going to be taking a look at some of the limitations of indirect truth table. Now in the last video I mentioned that really the only reason for learning direct truth tables was for formality, and usually I would just use indirect truth tables, and that's true. That's something I do. I would never use a regular truth table under normal circumstances. The problem is that there are limitations to indirect truth table, and we're going to be taking a look at some of those limitations today. So let's try to do this first example through indirect truth table. So assume that the premise of the main operator is true. We only have one premise, and that the conclusion, all these should be double slashes actually, that the conclusion is false. So this is a premise, the one premise, and this is the conclusion. So let's assume that the premise is false. Now, the material conditional is true when P and Q both have the same truth value. We don't know what those truth values are yet. P and Q could both be true, or P and Q could both be false. If P and Q are both true, then we get a contradiction right here in our conclusion. But if they're both false, then we don't get a contradiction. So their truth value is important, and we don't know what they are, and with indirect truth table, there's no way of proving whether this is a valid argument or not. So we have to go back to direct truth tables. So to do that, we have to outline all their values. So I'm just going to delete this true and false because it can't be done with the indirect truth table. So I'm going to give P its regular truth value, true, true, false, false. I'm going to give Q its regular truth value, true, false, false. Then we're just going to outline all the truth values of a conjunction, true, false, false, false. Remember that the conjunction is only true when both of its conjuncts, in this case P and Q, are true. And in all other instances, when they're not both true, it's false. Okay, so let's go to the material conditional. Again, we don't know what the truth value of the material conditional is for this premise, so we just have to outline all truth values too, which we already did right here. In the conclusion, true, true, false, false for P, true, true, false, false. And for Q, true, false, as we already did in the conclusion Q. Okay, so let's start giving its truth values. Remember that the material conditional is only true when both P and Q have the same truth value, which is either they have the same truth value of truth, or they have the same truth value of false. So right here it's true because they're both true. Right here it's false because P is true and Q is false. Right here it's false because P is false and Q is true. And right here it's true because they are both false. So let's just highlight these to kind of emphasize what we're comparing. And now, just with a regular way of proving that arguments are valid, let's look for a situation where indirect truth tables. Let's look for a situation where the premise is true, and the conclusion is false. So right here, the premise is true and the conclusion is true, so the argument isn't invalid right there. Right here the premise is false, so we can just skip the conclusion because the premise is false. Right here the premise is false, so we can just skip the conclusion. Right here the premise is true and the conclusion is false. So right there we have our contradiction. Let me change this. So right there we have our contradiction. The premise is true and the conclusion is false. And that means that the argument is invalid. And remember, we're doing, this is using direct truth tables. So by showing that the premises can be true and that the conclusion can be false and aligned, proves that the argument is invalid. If we did it by assuming that the premises are true and that the conclusion is false, and we found it invalid, then that would prove that the argument is valid. But in this instance, since we're using direct truth tables, remember, if we can find a line in direct truth tables where the premises can be true, or in this case the premise can be true, and the conclusion can be false, that means the argument's invalid. And none of these arguments we'll be able to do with indirect truth tables. And so in any instance, we're all going to be, in all these examples, we're going to be using direct truth tables. And so if we can find any line where the premises or the premise are true and the conclusion is false, then that argument is invalid. So let's take a look at the next example, again through indirect truth tables, just to kind of try to emphasize on why we can't use these with indirect truth tables. So the material conditional is false. The conclusion, the material conditional is false whenever P or Q don't have the same truth value. Now right here, that means that either P can be true and Q can be false, or P can be false and Q can be true. And you might wonder if that's important, and the answer to that is it is. If P were true and Q were false, we'd get a contradiction right here. Undo that. We'd get a contradiction right here. And if P were false and Q were true, we would not get a contradiction. So it's truth value matters, and there's no way to do it with indirect truth table. And additionally, look at the conditional doesn't help us, because there's no way with the conditional we can determine an instance where P is true and Q is false, as we could maybe if this was P and Q, then the answer would be obvious, because it would be P would be true and Q would be true. But we can't do that with this conditional, because it can be true on any instance whenever P isn't true and Q is false. So we have to do this using direct truth tables. So give P and Q the regular truth value, true, true, false, false. I'm going to move this line down a little bit, just give it more space, and then true, false for Q. First line, it's true. Second line, it's false. The other instances, it's true. And let's do the same thing with the conclusion, since we don't know whether on what instances the conclusion is true and the premise is false. True, true, false, false. True, false, true, false. And then right here we get true and false, false, true. Let's just highlight these, compare them. Okay, so right in the first line the premise is true and the conclusion is true, so no problem there. Second line the premise is false, so I'm just going to skip it. Third line the premise is true and the conclusion is false. So on the third line we see that the argument's invalid. We don't need to continue further. I mean, we can see on the fourth line that the premise is true and the conclusion is true, but it doesn't matter. As long as we get a true and a true premise and a false conclusion in any of the lines, or I should say, as long as all of our premises are true. In this case, I'm saying the premise because we only have one. But if we had more than one, if all of our premises are true and the conclusion's false, then that means that the argument is invalid. So as you can see, we proved that the argument's invalid, but we can only prove this using direct truth tables. Let's take one last look at one final example. So in this instance, P or Q, P is true, the OR operator is true, and the conclusion's false. So if the conclusion's false, that means that, if the conclusion's false, that means that either P could be false, Q could be false, or they could both be false. And in the OR operator, P could be true, in the OR operator, either could be true. So in this case, there'd be no way. It could be true if P was true and Q was false. It could be true if Q was false and P was true. It could be true if they were both true. So we have to delete it and use direct truth tables. So we get true, true, false, false, true, false, true, false, true, 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 false. Just like a regular line, remember the OR operator is true as long as either P or Q is true. So that's why it's only false on the last line. Let's take a look at the AND operator. We have to do the same thing. So we get true, true, false, false, true, false, true, false. We get true, false, false, false for the AND operator. Just going to highlight these and compare them. We get a true premise and a true conclusion on the first line, a true premise and a false conclusion on the second line. So I'm just going to highlight these red. A true premise and the false conclusion on the third line. We don't actually have to continue. I'm just doing this for example, and then a false premise and a false conclusion on the last line. So in this instance, through direct truth table, we got a contradiction on both lines 3 and 4. That means that the argument is invalid. So as I showed you with all these examples, that none of these arguments can be proved using direct truth tables. So this is, using indirect truth tables. So this is just one of the benefits of direct truth tables, that it can prove that arguments are valid, which indirect truth tables would be unable to do so. So for future references, just take a look at any of the arguments you might encounter and try to see if this kind of level of confusion comes up. If it doesn't, use indirect truth tables, but if it does, you can always fall back on the direct truth tables that you learned earlier in this course. Alright, see you guys next video.